So in this video we're going to look at composing a function with its inverse. So let's say we had this function f of x equals 2x plus 3, this is in blue. Well, the inverse of this function here is the one in green, and that is a half of x minus 3. So if we were to compose a function with its inverse, so what we would do is we'd be composing these two functions together. So we could do, say for example, the f of x, and then we could do the f2 of x. So we could do the f of x first. So we could start off at a point. Let's say we have a point here in this function which is x is 2. So when x is 2, then f of x is going to be 7. So we go along 2 and up 7. So that means that whenever we have done the composition, what we're going to do is we're going to go along 7 in this function here and see what we get. So we go along 7 in this function, that's 7 here, and we get to the point 2. So we're back to the point 2 again. So we started off at the point 2, we went to 7, and then whenever we went along to 7 here, we ended up back at 2. So this tells us then that whenever we compose a function with its inverse, we just get back to our original point, that is our original point x. So you could try that with other points along this as well, and you'll see that we always end up back at the point x that we started at. So in this instance here we start at 2 and we finish at 2. So we go 2 to 7 to 7 back to 2. So let's go and we'll write this out mathematically. When we compose a function with its inverse, what we're writing is the f of f inverse of x. So that's one way of composing it. The other way of composing it is to write f inverse of f of x. Now in both cases those will end up with a value of x. Now this is best seen by example, so let's have a little look at an example of this. So let's just talk through this example here. Let's say we started off with a function y equals 2x plus 3. Now what we'll do is we'll go ahead and we'll find the inverse of this function, and then we'll compose both with one another. Okay, so the inverse of this function is given by transposing this, so that's going to give us 2x is equal to y minus 3, so we're just taking the y across, the 3 across, and then we can take the 2 down, and this is going to give us x equals y minus 3 upon 2. So whenever we divide out, we'll have x equals y upon 2 minus 3 upon 2. And then what we'll do is we'll swap our x and our y's, so y would equal x upon 2 minus 3 upon 2. So therefore we can say that y is equal to, now we'll take out the common factor of a half, so it'll be a half of x minus 3. So this function here, y equals a half of x minus 3, is the inverse of this function here, y equals 2x plus 3. So what we're going to do is we'll go ahead and we'll find out the f of f inverse, and we'll find the f inverse of f, and we should get back to a value of x for both of them. So let's look at f inverse first of all, and then we put it into f. So what we're doing is we're starting off with our f inverse, this is this one here, and so everywhere we see an x here, we'll replace it with a half of x minus 3. So that's going to be 2 times, and this x becomes the half of x minus 3 all plus 3. So the 2 cancels out with 2 here, and you can see that the plus 3 cancels out with the minus 3, and we're just left with a value of x. So let's look at it round the other way. Let's look at f inverse f of x. So in this case here, we're going to do the f of x first, and we're going to place it into the inverse. So in this case, everywhere we see an x here, we replace it with 2x plus 3. So that's going to give us a value of a half of, well, the x gets replaced with 2x plus 3, and we still get our minus 3 here. So the plus 3 and minus 3 cancel out, the 2 cancels with the 2, and again we're just left with a value of x. So we can see here that f inverse f of x is equal to f of f inverse x which is equal to x. It's a bit of a mouthful, that. So again, these are best seen by example, so we'll have another look at this in the practice video. Thank you for listening. I'll get you in the next video. Goodbye.